guys, welcome to Thursday's lesson. We are continuing with chapter 9 today, which is still solving inequalities, although today we are going to be solving inequalities that contain absolute values in them, which are a little tricky maybe if you've never done them. So let's go ahead and take a look. So I am actually starting on the back of the notes, which are blank. There's only a one-sided notes today. But I am going to start on the back real quick. I want to talk about what a compound inequality is. A compound inequality basically means two inequalities in the same problem. And there are two types of compound inequalities. There are OR and there are AND. And it makes a difference which one you're dealing with. For instance, if you have x is less than 2 or x is greater than 5, for a number to be in the solution to this, it has to make this part true or it has to make this part true. But it only has to make one of the parts true, one or the other. On a number line, that looks like this. This is hopefully how you're graphing your answers on your homework. So I only need to put the important numbers in, which are 2 and 5. X is less than 2 would be these numbers. X is greater than 5 would be these numbers. And here is a picture of all the numbers that are either less than 2 or greater than 5. So if this had been an AND sentence, if this had been AND instead of OR, the answer would actually be no solution. Because for an AND sentence, both parts have to be true. And there is no number that is less than 2 and greater than 5 at the same time. Not possible. Typically, an AND sentence looks more like this. X is greater than 2, and x is less than 5. So you see we have the same two numbers, but now greater than 2 would be all of these, right? Less than 5 would be all of these numbers. But for an AND sentence, we only want to include the numbers that make both parts true. That would be this part where they overlap each other between 2 and 5. Those are the numbers that are greater than 2, but also less than 5. Typically, an AND sentence is between two numbers, where an OR sentence has two parts. And you might remember this from an earlier day, but an AND sentence can be written a different way than two parts. It can be written like this, remember? X is greater than 2, less than 5. This means AND. All right, so that's a little review of compound inequalities. Let's go to the notes. All right, so the big topic for today is these are going to include absolute values. So what does the absolute value symbol actually mean? Do we all know that absolute values are these two bars? I think we should. The absolute value of a number actually means is its distance from 0 on a number line. For instance, the absolute value of 3 is equal to 3 because the number 3 is 3 spots from 0. But the absolute value of negative 3 is also 3 because negative 3 is 3 spots from 0. Right? On a number line, three is 3 spots from 0, and negative 3 is 3 spots from 0, and it doesn't really matter if you're going left or right. The point is, the distance from 0 equals 3. And we can use a graph like this to help us solve these absolute value problems, I believe. Here we go. Let's look at example 1. So example 1, I'm going to do a really easy problem, but I want you to see how the graph on the number line, like I did here, helps you solve this problem. So I'm going to do the absolute value of x is greater than 2. Now that means that whatever values of x I have are more than 2 spots from 0. I want you to see what that looks like on a number line. It will help us in the next example, I believe. So we know that 2 and negative 2 are 2 spots from 0. But x has to be more than 2 spots from 0, right? So this x has to be out here somewhere. Notice I have an open circle around 2, and these are x values. Anything past that would be an x value that's greater than 2 spots from 0. And the same would be true over here. All of these could be possible x values. The x values are more than 2 spots from 0 to the left. And these two sentences, I believe, right here, this is what helps us solve this equation. I'm not sure that highlighting was a good idea. Both of these can be written as inequalities without the absolute value. I know on this side, x has to be greater than 2. And I know on the other side that x is to the left of negative 2, which means x has to be less than negative 2. And there's one more thing. Probably you can tell from the graph, but with the arrows going in opposite directions, this is like an OR graph. An OR graph goes in opposite directions typically. And this is an OR. Now I'm going to tell you, all absolute value problems create a compound sentence, either and or. And it's the symbol that tells you whether it's and or. And I have a cool way to remember that. When you have a greater sign, it's an or. Notice here I had a greater sign, making this an or compound sentence for the two parts that I wrote here. But if you have an and, if you have a less than sign, less than is an and compound sentence. And we'll look at one of those in a second. All right. So there's nothing actually to solve here. X is greater than 2, or x is less than negative 2 is our answer. And our graph looks just like the graph I made, which is probably going to confuse you because it's not always that way. But our graph would be numbers greater than 2, open circle, numbers less than negative 2, open circle. There's our answer as a graph. Let's look at a more difficult one. Let's do 2x plus 1, absolute value, is greater than or equal to 5. All right, I was going to do less than, but maybe we'll do less than in a second. So 2x plus 1 is greater than or equal to 5. Here's what that looks like on a graph. Now, this is not your answer. This is just what the original problem looks like on a graph. So here I go 5 spots because what this actually means is the distance of this amount, whatever's in the absolute value bars, has a distance greater than or equal to 5 from 0. So this 2x plus 1, whatever this 2x plus 1 is, it is greater than or equal to 5 from 0, which means it could be equal to 5, which is why it's a shaded circle, or it's this way. all of these numbers would have a distance greater than or equal to 5. So all of these numbers are possibilities for the 2x plus 1. Because again, the 2x plus 1 is inside the absolute value bars, meaning its distance is greater than or equal to 5 spots from 0. And the same is true over here, but now it goes this way. 2x plus 1 could be all these numbers. And my goal here is for you to see that this is an inequality. This means that 2x plus 1 is less than or equal to negative 5. And over here, this means that 2x plus 1 is greater than or equal to 5. And we could write those two things down. The 2x plus 1 has to be greater than or equal to 5. And on the other side, the 2x plus 1 has to be less than or equal to negative 5 to ensure that it is more than 5 spots from 0. And since this is a greater sign, this is an or compound sentence. And I would solve the two parts. I would subtract 1 from both sides, giving me 2x plus 1 is greater than or equal to 4. And I would divide both sides by 2 and get x is greater than or equal to 2. On this one, I would also subtract 1 from both sides, giving me 2x is less than or equal to negative 6. And I would divide both sides by 2 and get x is less than or equal to negative 3. So these are my solutions to this problem. Let me draw a graph, because we always like to put the answer to these on a graph. It's a nice visual. So the x values would be negative 3 and 2. These are my two key numbers, the two important numbers. Notice I put negative 3 on the left because it's smaller. 0 would be in here somewhere. I want to shade in the numbers that are greater than or equal to 2, so that would be a shaded circle there going this way. And the numbers that are less than or equal to negative 3, and that would be all of these numbers. These are the solutions to this equation. X can be greater than or equal to 2 or less than or equal to negative 3 for this original equation to be true. And then here's a picture of your answers on the graph. Let's do one that's a less than, and then real quick, it'll only take me about 30 seconds, I want to talk about an equal sign, okay? So, what if I had 3x minus 6 is less than or equal to 9, like this? All right, so I want to set up two inequalities, and I'm going to show you a cool way to do that when I'm done with this. But the visual way to do that is what we've been doing. I know that these numbers, this 3x minus 6, is less than or equal to 9 spots from 0. So like here's 0, here's 9, here's negative 9. This 3x minus 6 has to be less than 9 spots from 0. So from the 9, it has to be in here. These are the values less than the 9 that make this true. These numbers have to be less than or equal to 9 spots from 0, and they have to be less than or equal to 9 spots from 0 on the other side. So these are the numbers, the ones that are to the right of the negative 9. And again, both of these allow you to set up an inequality. And the inequality is this. The 3x minus 6 has to be less than 9. That's what this little arrow is saying. 3x minus 6 has to be less than or equal to 9. Should have had a shaded circle there, I guess. And on the other side, this 3x minus 6 has to be greater than the negative 9 if I want it to be less than 9 spots from 0. 3x minus 6 has to be greater than or equal to the negative 9. And this would be an and compound sentence because of the symbol here. It's a less than, making it an and. And I can solve both of these. But before I solve both of these, let me talk real quick about the cool way to set this up. The cool way to set this up is this, or the fast way if you want, if you don't want to do the visual. Although I think the visual helps you understand it better. But the fast way to do it is, you know when you have absolute value bars, there's going to be two sentences. And the two sentences are always the same. The first sentence is always the same as the problem. See how it's the same as the problem, but with no absolute value bars? The second sentence, you flip the inequality and you make it negative. Flip the inequality and make it negative. You do that every time. See how the inequality was less than, and I flipped it, and I made the 9 negative. Look how that works in our previous example also. See, the original inequality is what my first sentence is. And then I took this sign and I flipped it. And I made the 5 negative. And that's my second sentence. First sentence the same. Second sentence, you flip the inequality and make the answer negative. That's how it is every time. Well, let me go back to solving this. I don't think you really need help solving this. Oops. Lost my camera a little bit there. So, let me just go right to the answer. Well, I don't know. 3x is less than or equal to 15. X is less than or equal to 5 would be that answer. Over here, I'd add 6 and get negative 3, and then I'd divide by 3 and get negative 1. And so my graph would be numbers. Let's see, what are my two key numbers? Negative 1 and 5. I need numbers that are less than or equal to 5, but greater than or equal to negative 1. So that would be all the numbers right in here. And as usual, an AND graph is between two numbers, where an OR graph goes in opposite directions. Okay, real quickly, if you'll stay with me for one more minute, I just want to talk about an equal sign. What if you are graphing something like the absolute value of x plus 1 equals 3? All right, well, you do that the same way. You just know that x plus 1 equals 3, or x plus 1 equals negative 3. Notice again, I took the equal sign, I flipped it, but it's still an equal sign, and I made the answer negative. So again, the first equation is exactly like the original, and the second equation, I flip the equal and I make it negative. This would be x equals 2, right? And this would be x equals negative 4. And to graph an equal sign, you simply put a dot at the number. So my numbers are negative 4 and 2. I put a dot at negative 4 and a dot at 2. That's my solution, no other number, so I don't shade the rest of the line. All right, thanks for hanging in there with me. Good luck.